Hi, this is Ashley, and this is a recording for the fourth part of this project. And this part of the project is actually an overview and also a general understanding of where we're going with the rest of the project. So first of all, let's look at an overview of the project with the null hypothesis and the research hypothesis. The null hypothesis is that we are testing or trying to prove or disprove the null hypothesis, which says that the Mega Million lottery can only be won with a 1 to 259 million ratio. So the probability of winning is only 1 in every 259 tickets. And also the research hypothesis is that obviously that the lottery can be won with less than or a greater probability than 1 in 259 million. So the possibility of actually winning the lottery could be predicted with a couple of numbers. Now the reason we think that is because of some probability or statistical analysis that we can run, and we will go over a decision support system, which is a DSS. And in this decision support system, we have generated a group, or we have this list of lottery numbers or lottery winning numbers, about 500 or so of these numbers in this Excel document, and we have put those numbers in a ProstgreSQL document, software. And in this Postgres and Matlab software, that is our DSS technology. And those two pieces of technology will help us do data manipulations, storage, and also help us generate a group of random numbers and select and look up certain numbers to do our analysis. Now let's look at our initial analysis and discuss exactly what we're doing with the top 5 frequency, or the top 5 numbers in frequency for each of these columns. So the Mega Million has 6 numbers that are generated for each winning. So the first column will represent the first number, that is 1, and so on and so forth. So when we chose when we looked at all of the different columns, we could analyze each one separately, and we found previously in this project that the distribution showed to be normal. And the reason it showed to be normal is because we had so many samples, we had taken so many different samples that they gradually take the form of a normal distribution, and this is called the central limit theorem. So we have a general understanding that this group of numbers for the lottery follows a normal distribution. And now when we choose the top 5 numbers for each column, we chose them according to this MATLAB code right here. So if I scroll down in this Word document to the left, this specific MATLAB code grabbed the numbers from Postgres and generated the top 5 numbers in each column, and so I have them listed here. And then we just wrote out the top 5, or the top numbers for all of them, and it was 15 total. And those 15 numbers total were chosen as the best possibilities considering probability and statistics. And the probability of winning now will increase because we have a smaller sample of 15 numbers as opposed to 1 to 75 for each column. So if this theory works, or if this hypothesis, the research hypothesis, is proven to be true or to work, then we will have rejected the null hypothesis. So now let's discuss some of these hypotheses, and let's look at the null hypothesis first. In the null hypothesis, we have said that it's 1 in 259 million. Well, how did we get that number exactly? Well, we simply used a mathematical calculation, which is typical for a lot of probability and much of probability in statistics. So if I scroll down here to our former project problems that we have done, right here it says the Mega Million is 1 in 259 million, and that is simply generated with this calculation here. And each one of these divisions, 5 out of 75, 4 out of 74, and so on, are given those specific values because each time you pick or each time one of the numbers fall, then it has been taken from the sample, or the possible 75. So the denominator in each one of these fractions will reduce each time, and the numerator will also reduce. So you have 5 out of 75, 4 out of 74, 3 out of 73, 2 out of 72, and 1 out of 71. And then you have your Powerball, which is 1 out of 15 every time. And you simply divide that by 1, and you generate this number right here, 259 million. So the probability of winning the Powerball or the Mega Million is 1 in 259 million. But with our specific numbers that we have generated, we have a 5 out of 25 chance for the first number, 4 out of 24, and so on and so forth. So we have here the probability of 1 in 265,650. So it's obvious that your probability has increased, although it still doesn't look that great. But if you compare it to the number that we would have had in the hundreds of millions, then it's obviously a much better probability, and we have increased the chance, therefore rejected the null hypothesis, if in fact our research hypothesis is true or is proven to be true. So now let's look at the specific DSS rules that I have deduced from some of the little research that I've done so far. And my DSS rules are as follows. If you follow me through the right document here, this is the write-up that I have done on my research so far. So if we scroll down to the DSS rules for the lottery, I have listed here in this row you can see the numbers that were chosen for or generated for the top 5. So we're going to go ahead and keep those 15 numbers, but then we're also going to add these numbers down here, 41, 43, 45, and so on. Those numbers represent the lowest frequency numbers, and that is not a statistical analysis. That's simply from different research that I did on the internet showing people that have won the Mega Million multiple times, saying that they didn't use entirely statistical approaches. So we're going to kind of go half and half, with half of the numbers or using all of the probability, because I believe that theory has been proven multiple times. We're going to use those numbers, and as well as some of the top or lowest frequency numbers in each of the columns. And if you add those numbers together, you only get 24. So there is one number that I have to just randomly select, and I'm going to select the third lowest from the first column. That's pretty random, but we'll see if it works. And now the new set of numbers will look something like this list that I have here. So the idea behind these numbers, the probability of these winnings, or the odds of these winnings, are the same as what I showed you before with the 25, the number of the 25 numbers plus your sixth column. So the odds are still 1 in 265,650, but also when we finally generate some results, we'll be able to see whether or not this theory or the research hypothesis can actually reject the null. And if so, that means that some of our numbers in the generation gotten or retrieved from Matlab will actually produce a winning number. So that's pretty exciting, and I hope you have enjoyed this video and it's helped you. Thank you.